Alright, this is a quick tutorial on how to simulate an oscilloscope in TouchDesigner as physically accurate as possible. Using this, we can do some basic 3D projections, also draw outlines of shapes and morph between them. For example, between a cow and a horse, and draw some simple Lissajous figures using pattern generators here. So this part is our signal processing, and this part is the render setup and the geometry that we drive using the signals. And we will also be doing some post-processing at the end here. So let's get right into it. Close this out. Let's save it. And in our new file here, let's just delete everything. It's a bit technical. I'll be explaining everything as we go, but let's just start building out our channels. So we will be needing two pattern nodes here, pattern chops here. And how an oscilloscope basically works, by the way, for those who don't know what that is. This is an oscilloscope, and you can see that we have in the center here a little graph. This axis, the x-axis in this case, is based on time, and the y-axis, which is this one here, I can't draw by the way, is a certain voltage or a signal that is mapped against time. So as time goes on, the signal goes up and down like that. And this is a fun thing to do, but it's a bit boring since time is linear. We can't really go back in time as much as we might want to. The whole concept of oscilloscope art in our case is that instead of mapping time on the x-axis here, we will be mapping another voltage that can go in that direction as well. And for that, we need two signals, two voltages, or in oscilloscope music, it's the left and right channels. But yeah, using these two patterns here, we will be renaming these to X and Y. So let's put down two renames here. Let's do TX here and TY here because we'll be using these to drive our geometry later. And let's just merge these two chops into one so we have a single operator with both channels in them. And at this point we can already see what this outputs. So let's do a chop to stop here. And if we view this in the front viewport, you can see that it's a linear line going up, and this is as expected because the TX and TY values are always constant. So the fun begins where we kind of phase these two signals out of each other. So if we move the phase here a bit, you can see that we already have some geometry. And how this basically works, at each sample it checks out, okay, where is X and where is Y, and it plots that on that graph. And let's just finish up our little geometry section here with the geo node. So we have that out the way, a render node, standard practice, a camera comp, and we'll be using point sprites. So let's just put down a point sprite here. And the reason we use a point, the oscilloscope itself, it does not draw lines. It's basically a beam behind the screen here that beams forward in our direction right now, goes up like that. And in our audio world, this is at 48 kilohertz. So this happens like 48,000 times a second. And this just gives the illusion of a line, even though it's kind of just a dot that's moving really, really fast up and down. Sadly, though, we do not have 48,000 FPS in TouchDesigner. We might have that in the future, but right now let's stick with 60 FPS. if we calculate down the 48,000, basically 48,000 positions this beam moves down to 60 FPS, we will get, was that 800 samples. So at any given moment, if we break down the second into 60, at every given frame in TouchDesigner, we will have 800 points on the screen. So we can, if we want to do it physically accurate, we can set these to 800 length in the pattern. So we get 800 samples here. And just to visualize that, we will be turning our little line here into points using a convert. Let's do convert to particles per point. And just to see how this works, let's just do 4 here and close this out. And you can already see that we got 4 points. It's hard to see, but let's just render this out for a second with a RGB key, so we have a black background. And let's just already put down our final output node here. Let's call this something like, I don't know, finish line. Let's view this. You got 4 points here. Let's make them a bit bigger so we can see them. Also, let's assign this material. So we got 4 points here. And as the more samples we have, the more points we have. So at 60 FPS, and if we got 800 points in a frame, that's 48,000 points in a second, if I did not miscalculate that, which I may very well have done. And in our chop tool, let's remove the TZ here and the P2 here as well. So get rid of that nasty error message. Let's make this a bit smaller again, maybe 2. And this by itself is pretty interesting. We got 2 shapes here, or 2 patterns here, that we can already make some pretty fun. Let's move this down here, or up here rather. There we go, so you can see it. And if you've paid some attention in mathematics class, you'll know that a sine wave and a cosine wave, they generate a perfect circle. That's a fun little trivia math question there for you. It's not even a question, it's an answer. But yeah, let's animate our little cosine wave. Let's animate the phase here. So as you can see, if we move the phase up and down, it's going to change the shape. So let's type in the expression absolute time dot seconds. That's pretty fast. Let's multiply that by a quarter, and we already have our basic oscilloscope. You can see that the line here is kind of blurry. It's like not a perfect hard-edged line. That's kind of an issue that we have to work with. Let's just turn this back to 4. Let's make this a bit bigger. And you can see, or even bigger than that, you can see that the point sprite material is a hard-edged square. And we can use a different color map here. So let's just put down a ramp, a circular ramp in our case, and extend left will change to hold. And let's do a little Gaussian or semi-Gaussian texture here. So we got a bright spot that falls off left and right. And this right one should have an alpha of 0. And like maybe add another one so we clamp it down a bit. Maybe add another one here so we have some burning here. And let's drop this onto here. So that goes into our color map. And right now it's still got the background. In that case, let's turn on blending here. Yeah, so we got our little beams here. How the oscilloscope works, how it creates this line is this phosphorus material on the screen itself. It lights up when an electron hits it, and it decays at about 30 Megaseconds? Milliseconds. I'm sorry about that. Milliseconds. I can't write. So yeah, we'll do a little feedback loop here. Let's insert a feedback. So we have that little trailing effect. Let's do an add. And we'll be adding this on top of that. And let's put down a level here with opacity of 0.7 maybe, and drag the add onto the feedback. And now you see nice little motion blur trails. We don't have real motion blur in TouchDesigner as far as I'm aware of, so this is the best we can do. And yeah, let's give it more points here. Let's do 800 again. And we have a nice dancing ring here. We can play around with the patterns and how many cycles we have. This should be a multiple of the other one, or at least a integer. Can I do 3? Yeah, we can do 3, but you can't really put decimals behind there. You can technically, but it's kind of like not really a perfect loop then. So let's just do 3. Make this a bit smaller again. 10 was fine. And you can see that it's kind of dotted here. And in that case, we just kind of have to like not do it realistically and give it 2000s or maybe even 3000 points. We can also make these a bit bigger again. And if we want to get that nice blooming effect, obviously let's add a sweet bloom. And let's also add a lookup so it can change the color. And let's add a ramp to control the lookup. And what the lookup basically does, it checks for the darkest values and maps them to, or maps this color to the darkest values and this color to the brightest values. So if we, in our ramp, set this to like, I don't know, red, you can see the black areas are red suddenly. So let's give this a nice little soft teal color. Let's see. Yeah, the teal color probably works. I don't want it to be too bright. And let's give the curve itself, or the bright values here, I want to have some burning highlights, so let's leave that white, but move these kind of to a more greenish area, maybe even add one that's a bit more yellow. Something like that might work. Let's add also a comp node in the end so we can have our little overlay graticule, that's the word. And let's just put down a movie file in and select let's also make this, okay, let's go back here. Let's put this in. I got this from the internet, shout out. Let's make this full screen, by the way. And this is a nice little overlay. We can key out the black areas with a chroma key. And in our value, let's just set the min to something that contains all the overlay but without the background. Then also let's just make that white. So saturation 0. And I'll comp that in. Let's put this over that. And maybe add. Add looks fine, I think. And yeah, so that's the basic setup. We can control the camera. Let's set this to orthographic and zoom out a bit. Let's make that, I don't know, 6 looks fine. Let's move it up a bit as well so it's centered. And in our render, let's set the resolution to 1920 by 1080. And let's do 32-bit float in our pixel format. And yeah, you can play around with these patterns here. We can make maybe a triangle. So you got hard edges here. You can put down a square. Okay, that doesn't look good. let's put down our sound cosine back. Also, we can manipulate the input pattern here with another pattern and add a math node here. We can multiply these two together with combined chops. Let's multiply, and you get even more things to play with. Also, these need to be set to the same samples. Yeah, you can get some funky effects with this. Animate the phase here, maybe. Okay, that's too much. What if this is a square? That looks pretty good. Or pretty cool, at least. So this is how you would control it with patterns. Another way you can do things here is with simple 3D projection. So let's put down a box here. Let's put down a resample here. We'll need that later. Now let's put down a soft chop. You can already see our channels. We don't need the Z axis here, so we don't need to do this, but it's probably better to just use TX and TY. And let's also add a null here and put that on there. This is going to be our clean signal. I've never seen that. Okay, yes, please. So we can kind of just switch between these two. If we put this in, you already see our box in there. The resample, what this does, it generates more points, because if we don't have this, it's kind of just 1, 2, 3, 4 points. And if we do even length segments, we put this down to like 0.01. And middle click here, we see we have 2,406 points, which is nice. And we can animate this cube with a transform. And let's just rotate this on the z-axis with the same expression, absolute time, not seconds. Oh, I put that in translate. It should be in rotate. That's a bit slow. Let's multiply that by 10. And we can also put that here, maybe with some offset plus 100. Maybe even 0.25 here. Just play around with whatever shapes you want. Make sure they're not too far subdivided though, because then you get really messy lines and you can't really see anything. So, I mean, at its core, it's kind of just like a glorified, overly complex wireframe renderer at this point. But let's multiply this by 10 maybe, so it moves more. And the third way you can make fun shapes is using images. So let's get a movie file in. Let's grab our cow. It should be white on 0 alpha. And let's just drop down a fit if we want multiple images, so we have control over how big they are. Maybe 1500 is good. And let's drop down a top to, no, not a top to, a trace sop. So we have this object, and the same goes here. So we can do sop to top. We got that. Also, let's just select the TX and TYs here. And if we plug that in, you see our little cow image. Right now, let's see, we have 686 points. And if we want more points, we can just stretch out our chop here using the aptly named stretch chop. And in here, let's change this to absolute and change the n to how many samples we want. Let's go with 2000 here. Copy and paste this. Also, let's add a transform sop here. Put that on there, and we can scale up our cow a bit. And the same one here. Let's put that on that. Parm sop. I love Parmesan. And in here we can use maybe a horse. And the way we switch between these two is using a cross chop. Why did that move? Let's put both of these into our cross here, and let's pipe the cross into here. And if we move the slider in our cross, we have this nice little morphing animation. Right now it looks pretty good already. We can add some details, like some subtle flickering or distortions. So one way to do that would be, let's just grab our cube here again. One way to do that is after our clean signal. I'm moving so far left here. I've never been this far left in TouchDesigner. So let's put down a second null here. Let's call this, I don't know, dirty signal maybe. And put that onto the chop tool. And in here we can do a math chop and another pattern chop. And if we just pipe this in and do combine chops by add, you can see that our points are going everywhere right now. And if let's just put down the amplitude on our pattern here, you can see that the larger this chop here is, the further out it goes. First of all, let's animate the face here so it moves a bit. Perhaps time not seconds. Let's put down the amplitude, and let's step up the cycles, so we get more cycles, sort of like a little wobbling effect. I think 40 looks fine, and let's just go down with the amplitude, and let's make this a bit faster, and let's go even further down with our amplitude, maybe even further down. Now we got this little wobbling line effect. And the last thing we can do here in our point sprite material, we have this alpha. And if we move this really fast, you can see it's kind of like blinking. We can control that with another chop here. Let's use a noise. Let's put this in. Let's turn on time slicing, so we get a random value. Let's put down a math after that. I believe this is going from, just put down a trail to see where it's going. This is going from -0.5 to, or is it going from -1 to 1? I think it's going from -1 to 1. So let's put down -1 here. And I want a range of 0.8 maybe to 1 in opacity. We can put down a null here and call this flicker. I cannot type. And let's put this into our alpha. And you can see some subtle flickering. We can make this a bit faster with less period. Maybe 0.1 is fine. And it's basically flickering between 0.8 and 1. Let's see if it even does anything. Yeah, it does. Yeah, so let's put this to 0.7 maybe, so it's more obvious. So yeah, that is the basic setup. You can put some CRT effects behind here. You can put other shapes in here. You can load 3D models in here. Just make sure they're very low poly, so you can even see anything. And I'm just thinking if I forgot anything, but I think I covered it all. So yeah, let me know what you think. Let me know if you built something cool. Let me know if you got any questions. Leave it a comment. Leave it a comment. Leave it as a comment down below. I'll probably make a CRT emulation video soon, and maybe we can use this as a basis to simulate how a CRT screen works. And yeah, this is the oscilloscope. Thank you for being here, and I'll see you in the next one.